All right, so welcome to my talk on generators. So tonight's a nightly night, as I like to call them, where I pick out a um, fun or interesting looking nightly feature, um, and I talk a little bit about it. So I'll be talking about like what this feature is and like why it's useful, the current state of it is, and I generally like to do these just because I want to learn more about these features myself. So yeah, so today I decided I would learn a little bit more about generators and just give a brief talk on those. It should be fairly approachable for beginners. So I'll be kind of skimming over like the really nitty gritty details, but um, yeah, let's just kind of dive into things here. So like I said, we're going to talk about what generators actually are, why generators, and I'll be talking about some of the challenges that um, the, uh, the compiler team has faced in implementing generators, stabilizing them. So, what are generators? Well, generators are just suspendable and resumable functions. So, basically, they are suspended using a yield keyword. You've probably seen this keyword in other languages, especially if you're familiar with Python. Python seems pretty popular these days. And it's also in JavaScript. I believe C# also has generators using yield as well, although I'm not 100% sure. And specifically for Rust, at least as of today, with the current implementation of generators, um, any closure containing the yield keyword becomes a generator. So what do I mean by that? Let me just jump into an example here. So we'll just hop out of the PowerPoint for a moment. Let me just maybe boost the size of this so it's a little more readable. So here I have an example just in the Rust playground showing off how generators work. So if you've never seen this before, you can select the nightly channel here. This lets you use unstable features. So here I've declared that I want to use the generators and generator trait features. And yeah, you just import a generator, the generator state types. You also need pin. I could talk more about pin, but I think I will leave that for another time because I think there's enough to say about pin that I can do an entirely separate talk on that. So I'll be kind of skimming over the details of pin. Basically, the important thing that you need to know is here in main, we have this closure here, and this closure is actually a generator. So the reason why it's a generator is simply because it has this yield keyword inside of it. So if you don't put a yield anywhere inside of your generator, it doesn't become a generator. It's just a closure. So this defines a generator, and we can actually kind of step through this and see what's going on if I run this. So if you've never seen this before, basically when you create a generator like this, it doesn't actually execute anything inside of it. Instead, you have to call this resume function. And once you call resume on your generator, then it'll actually start executing it. So the first thing we see is before yield 1. So that's basically going to run the generator up until this yield here. And then it's going to yield this value 1, which we can see here. So we actually match on resume here, and that yields control back to our code here and allows us to check what we got. If we didn't get a 1, then we would panic. But instead, since we got the 1, we're just going to we're just going to print yielded 1. And then we're going to continue. We're actually going to continue down here to the next call to resume. And so when we call resume, since we used yield to suspend at this point, we're actually not going to start from the beginning. We're actually going to start right from this yield, and we're going to print before yield 2, which you can see down here. And then we're going to yield the next value, which is a 2. Again, we do the same thing. We panic if we don't get the 2. And then finally, we call resume one last time, and we print before return, and then we return foo. So we'll come down here and check that the generator state is complete, and we got this this foo string, and then we'll just print return foo. And that's pretty much everything that this code does. It's not super complicated, but yeah, you can kind of see how it kind of ping pongs back and forth. Every time it yields, it goes and continues execution out here in main, and then once it calls resume, it continues from the last yield. And one thing I want to note is that this return here, I don't think is actually necessary. I'm pretty sure that if you just omit it, it works. Yeah, I don't really know why all the examples in the book, when looking at the unstable features book, it literally says like all the examples literally have this return here. I don't know why. I feel like it's unnecessary, but I don't know, maybe it's a stylistic thing. Another thing I want to note is you'll notice that resume actually takes a unit. That seems a little bit weird because most functions that don't take any arguments, or at least take an argument that they aren't going to use, are not going to, they're not going to explicitly take unit. You shouldn't need to do that. And I'm not 100% sure about this, but I'm like 90% sure about this. And the reason for why they do this is because there is another feature that you may have heard of called coroutines, which is very, very closely related to generators, in that they're sort of like a generalization of generators. And so the thing about the coroutines feature is that unlike generators, they can also receive values. So you could also say like let a equals yield 1, and you'd be able to pass in some value here. Like you could pass in like, I don't know, true, for example. And then this would get true once it resumes and continues from this yield. So so it's yeah, it's definitely kind of hard coded right now. I can actually kind of show that off once we get to the next slide here. So this is what the generator trait actually looks like. You'll see in the generator trait that it takes a type argument, and it's defaulting to a unit. And what's kind of interesting here is that resume takes that a value of that type R, and because it's unit for generators, you're never going to actually be able to pass in anything other than unit. Like if we could try to do something like this and then pass other values here, like booleans. But as far as I've seen, it doesn't actually do anything. So I think this might actually require an argument here. Now I think about it, because there's 3 resumes. I'm not sure. Okay, actually, it can take other arguments then. Never mind, I was wrong. Because I thought I tried this before, but I think it's because I forgot about this. But yeah. Maybe there's more progress on this than I thought, but the state of this feature is, it's changing. So yeah, I'm not 100% sure like what actually is supported or not right now, but I do know that what the aim is to stabilize just the generator feature and not the more generalized coroutines feature, because apparently there's more design considerations around that still that need to kind of be worked out. But yeah, anyway, the other thing that I want to note is that generators, they return this generator state from their resume function, which is what we saw down here. So that's this enum that we match on to get the state of whether it's yielded or complete. So interestingly, the generator state can have two different types. So as we saw in our example, all the yields have one type. All these yields are returning an integer, and the return itself actually can be something completely different, like this string foo. But if you try to do something like return or yield true and yield two, that wouldn't work. So that's not possible to do. We can even show that off here. Yeah, expected bool found integer. So yeah, that's basically how the generator trait works. And here's just a quick comparison of generators and coroutines. So generators can return values when paused, but coroutines can both return values when paused and also receive values when resumed. Generators are usually suitable for iteration because all they do is return values. And so you kind of think of a generator as returning like an iterator. I don't know if that's exactly what it's doing here, but because we're not calling next on this thing, obviously, we're calling resume on this generator. So I don't believe it's actually like a regular iterator. I believe there are actually some issues with that, which we'll talk about later. Whereas coroutines, they're not strictly suitable for iteration. So when coroutines eventually get implemented, if they eventually get implemented, um, they because they can take values as well, you can't really treat them like iterators. And lastly, one kind of interesting thing I wanted to point out is that generators implement the generator trait, but because of how they've kind of named things here, coroutines also use the generator trait, which is a little bit confusing. And I imagine that this might change someday in the future. I'm not sure about that, but yeah, at least from what I've read so far. I mean, I don't know like the exact like current state of everything right now. But I did read like some blog posts from like Without Boats from like a couple months ago. So
I
all
think
information
Amin has a question.
sure, ask away.
Hello. Sorry, I was late a bit. What's the benefit of generator over a simple iterator?
So yeah, why generators? Uh, it's mostly just a convenience, actually. So you can write iterator impls in Rust to do like infinite streams and stuff like that. Like I've seen examples in other languages like JavaScript where they're like, oh my god, you can use generators to like implement like an infinite, stream and like a bunch of other stuff. But then when you look at Rust, it's just like, oh, you already have like the iterator trait, so you can already do that stuff. So like why generators? Um, there aren't a lot of really practical use cases I can find. Like it's sort of a lower level feature that is mostly going to be used for async await. So async await kind of, well, so async await right now compiles down to a state machine, but they want to be able to use generators or coroutines to implement that transformation because generators will also compile to a state machine. So when they stabilize this, I think what they said in the RFC is that they don't intend on teaching it because you're not really meant to use it. There's not a lot of like practical use cases for generators outside of just like, oh, it makes it easier to write some imperative code that like yields control away and stuff like that. Maybe when it what they I think they are planning on implementing coroutines. So I think coroutines may have more usage for implementing like state machines, but Otherwise, like as it is right now with generators, I mean, yeah, you can do pretty much everything you want, just implementing iterator instead. It's just less convenient. Um, Another interesting thing about how generators are implemented specifically in Rust is that there's no implicit memory allocation. So usually there's some kind of stack that gets allocated, but with Rust, the way that it's translated to a state machine, they're generally considered to be stackless. So you'll see the terminology stackless coroutines crop up quite a bit in a lot of the articles and I think in the RFC for generators as well. But yeah, it's kind of a nice benefit. I imagine the coroutines implementation is going to be a little bit more complex, but yeah, we'll see how that all goes. Uh, there are a few challenges as well for stabilizing generators. So uh, largely, they're broken down into two categories. There's syntax questions, and then there's semantics questions. So I'll just dive into a couple of the syntax issues. There are more, but these are the ones I felt were kind of the most interesting, I guess. So, like I showed earlier, you can make a closure into a generator right now by adding a yield to it, but you'll notice that there isn't actually a way to make a function a generator or a block, right? So async has that ability right now. Like you can make an async fun and you have an asynchronous function, but you can't do that with generators because, well, they actually don't have a keyword for it yet. And the keyword for generators wasn't reserved in edition 2018. So most likely there won't be a keyword for this until 2024, which means that this feature probably isn't going to be able to stabilize until 2024 at the very least. Because I'm pretty sure they fully intend on implementing generator functions and generator blocks. The other issue that has been kind of talked about quite a bit is what the return type should be for generators. So currently, with async await syntax, you don't write like impl future all over the place when you're returning values from async functions, and that's a conscious decision that they made when designing async await because they wanted to get rid of that extra boilerplate. It wasn't really necessary. And so there's a similar discussion happening for generators. I think without boats is in favor of leaving out impl generator because that's just annoying. It's just noise in the syntax. But there have been a number of people raising concerns about this, and so he suspects that this is something that will be relitigated in the future. So that's one of the other big issues, or maybe not a big issue, but that's one of the syntax issues. In terms of semantics issues, something that they've been kind of working on is how to deal with return expressions and the question mark operator in generators. So this is specifically more about like early returns or like having the question mark operator be used, in between yields, right? Because all these keywords are used to, well, I guess they're not all keywords, but the return expression and question mark operator do affect control flow, and so does yield. So that's something that they've been kind of dealing with. I think the current implementation kind of handles return pretty well, as far as I can tell. Like I did play around with it a little bit, doing early returns in between yields, and it didn't do anything unexpected. So that might be something that they've already kind of worked out by this point, because, like I said, everything that I've got here was from a blog post from a couple months ago that without quotes made. But the real big issue that they're still tackling right now, I believe, is self references. So the problem with self-references is that the iterator trait has already stabilized, and so it's been stable for quite a long time, and it doesn't support self-references. And that's kind of an issue because they want it to be able to support self-references. So there's been several ways or several approaches proposed, like I don't know, maybe adding a new type that like wraps iterator and then implements whatever is necessary to support self-references. So I think it requires like pinning or whatever. But yeah, they also suggested having async iterators be able to support self-references and have the regular iterator trait not allow it, because so far this hasn't really been an issue. Like no one has really been asking for this for iterators, so they think that it would be nice to be consistent, but at the same time, if we haven't had an issue with it until now, then maybe it isn't really like an important use case, and we can kind of get away with just saying async iterator will support self-references and iterator just won't. But yeah, this is apparently an issue that can't be fixed even with Rust additions, which is something that I thought was kind of interesting. I always see people saying, "Oh, Rust will be like future proof; it'll last like forever and ever because we have additions. Additions will fix everything, but additions don't exactly fix everything." So yeah, that's pretty much everything that I had for today. Here are some links. I will be posting up the slides to our repo later. But yeah, these are the links that I got a lot of my information from. And again, just to reiterate, I'm not an expert on generators. I wanted to do this talk on generators so I could learn a little bit more about them. And I feel like I have like a very high level understanding of how to use generators and what they're about. And that's pretty much what I was aiming for. So when this feature lands, I'll know like where to use it, how to use it, and like, when I should. But yeah, that's it. If you have any questions, then feel free to ask away. Peter?
Thank you, Jonathan. What is the need, or why self-referencing, or why the self-reference in generators, please?
Okay, so the self-referencing is because, well, okay, I can't really speak to it, but if you are familiar with how async works in Rust, you'll know that a lot of types require pin, because a lot of those types are actually self-referential. And so for async iterators, this makes a lot of sense. I don't really know why for iterators specifically they want this. I guess so they have a unified API and it's very consistent. But I mean, the solution that they seem to be leaning towards right now is just saying we're not going to bother having self-references for iterators because no one's ever needed them really until now, or even now. So yeah, but it makes more sense for the async iterator to have it because async types generally tend to be, they generally tend to require pin, but otherwise, yeah. And if you want to know why async types require pin, I don't actually know. All I know is that it's in the async book. I'm in.
Yeah, so one of the issues I had with async await was in the recursive calls when there are lifetimes involved, and for example, you're passing some object into async block, it usually the compiler cannot understand the lifetime, and it's nags about infinite recursion and stuff. Will this solve that issue in some way?
Probably not. Like, I don't think generators will help with that at all.
The reason I say is, like, for example, I once tried to move some code that was using Rayon threads. It was just simple parallel iterators. It worked with that, but then I tried to use async await. I was getting so many compiler errors, I just gave up. So I think generators would be like Rayon iterators, but with async await support somehow, if I'm right.
I can't really speak to that. I don't know. I don't know too much about async await and Rayon. I
Okay.
don't know if anyone else has experience with that, but yeah. Sorry, I don't really know. Maybe you could show us your issue that you're having. Maybe we could try and help that way, but otherwise.
Yeah, I can make some simple example. So basically, using Rayon threads is very easy, but when you try to use async await, it becomes so hard. And Rayon threads, you use iterators, which is basically the underlying implementation of generators. So if generators support async await, I'm saying maybe it simplifies the things. I guess we should try that. So I haven't seen the generators.
Maybe, yeah, maybe. I mean, you can try generators today on Nightly.
Okay.
Obviously, they're not going to stabilize for another year, at least, because of the keyword issue. But it is something that they've kind of said has been kind of sitting around for a while. Like, generators are kind of almost ready to go, and they've been in this state for months now. But yeah, these last few issues are kind of causing a lot of contention, and no one's really uh, come up with like a solution that everyone's happy with and that they're ready to stabilize with. So I don't know how soon it'll be until they actually drop, but I imagine that they will try to push for this to be finished sometime in 2024.
Right. Worth trying.
Does anyone else have any questions, comments, feedback? Momori?
Oh, yeah. Yeah, so nice to meet you. And
Yeah, nice to meet you.
yeah, and thank you for the presentation. I am a beginner to Rust, so I actually didn't understand everything, but it was interesting. And I used to use C#, and it has a similar function like generator, so it reminded me of that. So, and yeah, as a beginner, I am interested in how to learn Rust. So, where did you find that kind of information, like generator or something?
That's a good question. So the way that I learned Rust was I go way back to 2016. I actually picked up Rust like a year after it stabilized, and I read like the first edition of the Rust programming language. So that's like the free book that they
Yeah,
recommend. Yeah, and there's a bunch of newer resources now that I think are probably a lot better. I mean, there's a second edition of the book now at this point as well, which is much more comprehensive than the first, which is the edition that I read. So, yeah, it's it, okay. Yeah, someone posted comprehensive Rust. That sounds like something that might be useful to you.
Mhm.
As for how did I learn about generators? Honestly, it's just I like to browse like the subreddit for Rust,
Mhm.
and sometimes I'm looking around and I'm googling for solutions to my problems, and I'll see something that catches my eye, and like the sidebar of like Stack Overflow or something, and
Mhm.
click and I'll that's generally how I kind of discover things. But there's also the Unstable book, which Thereupon here has linked. And the way that I've been kind of doing things recently is I will literally go into the Unstable book and look
Mhm.
for a feature that catches my eye, something that looks interesting. Maybe I've seen someone talking about it and they made it sound really interesting or cool. And then yeah, I'll just kind of click on it and learn a little bit more about it, and try and figure out what to do with it. I mean, basically, for me, it's this sort of like it's sort of like content creation. Like I just need to find something to talk about for the meetups, and
Mhm.
I like doing these nightly nights because for me, it's just like a good opportunity to learn about something new, um, and also check out like some of the cool upcoming features in Rust to you know kind of keep me more engaged with the language. So yeah, I just like to look through the book and pick out stuff from there.
Mhm. Okay, thank you. And yeah, Thereupon and Ali, yeah, thank you for recommendation.
Yeah. There was also there's a Rust Twitter and also a Rust weekly mailing list. They also have some interesting links every time for different.
Yeah, there's this week in Rust, I think,
Okay.
and they also advertise like other meetups. They advertise our meetup as well.
Yes, that's how I found it.
Yes. I think they might also like advertise some interesting podcasts as well. I know Chester's picked up quite a bit from listening to podcasts on
Mhm.
Rust. I personally would just like to get my hands dirty and mess around with Rust to learn more about it. So sometimes I like to just play around with the type system and try and figure out how it works. Compare it like what I used to do was I would take like a cool article in Haskell and then try and like translate it to Rust and see like how easy it is. Is it possible? Like what ideas actually translate? And that's how I got a lot more familiar with the type system and how it worked. There are a lot of similarities. Like the new type pattern isn't something that Rust invented. That's from Haskell. Um,
Mhm.
there's a bunch of other ideas that they kind of just were inspired by Haskell. So the Little Book of Rust books. I've never seen that one. Anyone else have any other questions? Comments?
I have a unrelated comment about unrelated to generators. Uh, do you guys like contribute to any open source project or something in Rust, or any idea about how would one start or something?
I think I may have contributed to one or two in the past, quite a long time ago at this point. I think it was a little bit easier to contribute earlier. I don't know, but I guess I've also been kind of busy lately. I haven't really touched any, or I haven't really contributed to any open source Rust projects in a while. I know some people who contribute to the compiler, and that's how they learn how to understand what the compiler does uh, fairly deeply. But yeah, listen to Chester. He has good advice.
I've contributed to many projects, but the way you find it is just you need to be curious and find issues and solve them. There's no like solid way.
Yeah. Thank you. Yeah. Uh,
And if you have like some issue with some package, go fix it and make a PR. You know.
Yeah. Thank
All
you,
right, since
Chester.
oh, go ahead.
Yeah. Thank you, Chester, as well. Yeah, I'm reading. Thank you. Thanks. Yeah, Jonathan.
Any other questions or comments or anything? Either about the talk or maybe not related to the talk? 'Cause I feel like we can kind of just transition into free discussion at this point. I don't really have a specific agenda. Actually, there's one thing I wanted to talk about today, um, uh, which is the office. The office is supposedly reopening mid-October. I know some people are really excited for this. They really wanted to know when are we going to actually have a venue finally? Because it's been a little while since the pandemic ended officially. So yeah, the official update from the contractors is mid-October, and I do not. I would take that with a grain of salt because these things tend to get delayed. But yeah, we'll see. We'll see what happens. Does anyone have anything interesting that they want to share, or any other questions? Something we'll talk about? No, as a hobbyist Rust game developer, I do want to say I think that the current situation with Unity is pretty interesting.
Yeah, that's interesting. I sometimes watch this Primogen on YouTube. I don't know if you guys know him.
I think yeah, he's a pretty popular
Yeah.
programming streamer,
Yes.
YouTuber.
Yeah,
Correct
yeah,
him for sure. Yeah,
yeah. That's a good way of sometimes hearing about these kind of news.
yeah. I think Unity's kind of shot themselves in the foot here. I know a lot of people are suggesting going to Godot, but I thought it'd be also like a good opportunity for engines like Bevy, to get more people on board. I will say that the current state of game development in Rust is kind of, I wouldn't call it like abysmal or anything. It's just not, it's just really not there yet. Like I've had struggles with pretty much every engine that I've tried to use in Rust. It's not really, it's not as smooth as using Unity. Even Fireox, which is, kind of similar to Unity. I had some issues with that as well, like the physics kind of bugging out and the character getting stuck on the floor. I believe I showed this off in the last meetup that we recorded. So maybe not everyone's first choice as an alternative to Unity, but it is, it's certainly something worth exploring. I feel, and if you're interested in doing game dev in Rust, maybe worth contributing to. It could be a good open source project to look at as well if you want to contribute if you're
Yeah,
interested in game dev.
good idea.
Uh, No, since that's the kind of stuff. To backtrace.
Yeah, this vector's interesting. Definitely will check it out.
Yeah, that PR has been stuck since last year. It's so I basically added profiling support on Windows. I don't know if you have used pprof. It only works on Linux and Mac OS, not on Windows. So this adds support for that, but there are some there were a harsh review on the PR, and it's kind of hard to convince the core maintainers to merge that.
Yeah. I don't think that will be of much help in convincing them, but see how it's some very recognizable names here. Yeah. I mean, they're kind of authorities and been around for a long time, so it makes sense that what they say would go. I don't know. Probably just have to talk to them some more and kind of come to some kind of agreement on what to do. But
Yeah,
that's that's the best I can. That's the best advice I can give you. Unfortunately, they're probably quite busy.
yeah, me too. That's why I didn't answer to the last review.
I see.
So I guess I have to put some time aside and go back.
Yeah, I mean, I've been kind of struggling to find time to commit to, personal projects in Rust and other, Rust related research. Because yeah, it's been very busy these days, and the economy has been kind of bad. Yeah, yeah.
Regarding Chester's comment, so I've done the Windows part. So basically, one of the comments was that this feature is being added only for Windows, and we need to have it for all platforms so that we can merge it. While we only need it for Windows because that's how profiling works on Windows. So that's like they're saying this feature is missing for Linux, while it is not useful. That's the state basically.
Hmm. I mean, maybe they just don't understand that. They need that to be explained to them a little bit better. I mean,
Yeah, probably better
don't know.
communication.
And I wish I could help, but it's not really my wheelhouse.
Yeah, I understand. It's quite low level. So
All right. Anything else? Anyone else wants to talk about? There is actually one thing I might need to talk about today that I kind of forgot about. But I have to sign into my. Actually, no. Let's see. Yeah, I just got a reply about this today. Um, oops. So last year we did a, I guess, partnership deal with API World 2022, and this year they wanted to offer the same thing. So I'll just mention right now that doing that partnership again this year. So it's like a conference, and you can check it out if you want to. Unfortunately, I haven't had a chance to look at all this stuff yet, so I don't have the links ready. I'll be posting them a little bit later, but there might be free passes for this or discounts on passes if you're interested in going to the event. I might be able to provide, but yeah, I'll just post the details later. I don't want to fiddle with this right now. All right. Well, if no one else has anything else that they want to talk about or any articles that they want to share, then I think we can call it here. We can call it a little bit early. So I'll give people like, I don't know, 5 seconds if they want to jump in and say something right now. And once, and twice. Okay. Well, then I guess that'll be it for today's meetup. Thank you all for coming. I really appreciate it because our meetup is pretty small, and these meetups don't happen unless people actually come out here and show up, even if it is virtual for now. Still, I swear we will have a venue. It will happen. I can't promise exactly when, but it sounds like it's going to happen soon. So yeah, please be patient as always, and yeah. Thank you all for coming, and I will upload the VOD for this meetup probably this weekend and post a link to it in the meetup event description in the comment section. And yeah, take care, everyone. Hopefully, I'll see you all next month.
Oh,
See
thank you. Thank you for
Yeah,
having me today. Yeah.
All
See
right.
you.
Bye.